Hey guys, and today I've added something that is truly disgusting. As you know, I kind of like iterative processes, and I've kind of taken an iterative process and made it one of the most disgusting things that you can imagine. So this is a centipede, and it can be as long as I want it to be, and it truly is absolutely horrifying in the way that it moves. But the actual amount of commands is quite small, and it's a pretty simple method. And yeah, this thing can come after you and kill you. So if I go into adventure mode, and then I go and hit the head, because it is, oh my god, it's just moving so fast. Okay, now it's coming after me. It is gonna come after me. Oh, no, it's running away. Look at the thing swim. Oh my god. Oh, it's gone. Oh, it's gone. He moving. He moving. What am I watching? Oh my god. Okay. So anyways, let's just get into the explanation of how it works. It's going to be pretty quick, but it's kind of entertaining here. So I've hopped into a single player super flat so I could better demonstrate the fact that yeah, this thing works. It kind of follows itself. And it really looks like a centipede besides the red eyes coming out of some of the segments. It does collide with itself, which obviously you can change if you want. It'll make it move more freely, but also be a little bit less cool, like it'll be able to run over itself a lot easier. And one thing to note is only the head can attack you, because the rest are no AI spiders. But yeah, it looks really nice, and it also works with multiple, so we can have a couple come after us. But you're going to start lagging because this is 40 entities in one location, which naturally is going to be kind of laggy just because there is so many things coming at you. But let's cover how this is done with commands very quickly. I'm not going to be releasing the data pack. You can pause and copy the commands if you want to, if you're that obsessed with this design. But I'm not going to be releasing the data pack on its own because I don't think that it is complete or does everything that I would want it to, because I still want to implement a method for making it so if you damage the body, it damages the entire thing, which is going to be a bunch more commands that I don't really want to show. Anyways, so it's quite simple. It's actually just two functions. So inside of main, let me close everything so you can see this a lot more clearly. I'll zoom in on the text so that if you're on mobile, you can see this easier. So I made a team for them so that I can mess with the collision rules so they can either push other teams or never push anything. And then I made a scoreboard called Centipede, which is basically a scoreboard that holds a number that identifies which centipede it is. That way you can have multiple. So inside spawn, I spawn the centipede with a tag of centihead. So this is the head. And then behind it, I spawn a centipart, and I give a unique tag to the centipart of 0. There is a way to do this without having hard coding, as you'll see in this video, but it's actually more efficient to do this kind of hard coding, I think, and it's a lot easier to handle. So this guy has a tag of 0. This is the exact same spider, but it has a tag of 1, and this has a 1 at the end. This one has a 2 at the end. So basically, each one has a unique tag identifying which piece of the limit is, and all of them have a tag of init, and anything with a tag of init gets a scoreboard value, and this scoreboard value will be one higher than whatever the previous scoreboard value was, so each one will have a unique scoreboard value. Global is just a counter. It counts up 1, 2, 3, 4, 5, 6, 7, so it'll never repeat itself unless you get to past 2 billion, cycle down to negative 2 billion, and back up to 0. Then it'll repeat itself, but by then the universe has been destroyed. So then you remove the tag. Simple to spawn. And then I have a check for a score so I can change how long it is based on a fake player on the score. So let's take a look at the scoreboard. Let's go scoreboard up to, so they sidebar centipede. All right, so you can see that global is 16. That means I've spawned 16 over the course of me testing this. And the length is 20. And search will come over later, but that's how we basically differentiate between one or another. Okay, so that's all you do. That's how you spawn it. Okay, so then in the only other function is you have a ticking function. This function is played every tick, and you go to a centipart, which is not the head. The head is not a centipart. Only the body parts are a centipart. And you run the centipart function. Okay, so then the centipart function essentially is going to do a couple things. So first, it applies some gravity because no AI spiders don't have gravity. So it applies some gravity, and in this case, it moves down by 0.1 blocks as long as it is still in the air, if that makes sense. So if there is air below it, then move down a little bit, and it does that every tick. So it travels at about 0.1 blocks per tick, which gives it kind of minor gravity. It's not gravity similar to the game, and obviously it doesn't have acceleration, but it does provide some kind of movement downwards so that things don't get stuck in the air and look weird. So now we go into the actual meat of this function. So we copy the centipede score of the centipart onto a search or a fake player, and this is basically a fake player we can check to see if it is the right part. So then we go to all the centipede parts, every single part that is spawned, which obviously is kind of an expensive function to run, which is why having 40 mobs at once can start to get laggy on top of the base game's 40 mob kind of hit. So we go to all of them and we see, do they have the same score? So if there were 2 alive, then some of the pieces of the centipede that you go to will not have this criteria of being the same score. But if they do, add a tag of this. Okay, so this is kind of a tag that's going to let us know if you're acting at the correct, like which piece is a part of the same centipede. Okay, so then this is a repetitive iterative process, which obviously could have been done recursively with recursive functions, but it's more efficient to do it this way, honestly. So we check, are we the 0th part, or the first piece besides the head? Then we are going to go to the head, which is the piece in front of me. We are going to face myself, so it looks backwards towards me. It moves in that direction by 1 block, and then it teleports me to there, however, facing the opposite direction. So essentially what this does is, let's say that this block is the head, and I am the butt, okay, or the piece right behind the head. It will, if I'm like here, right, I'm positioned here, it will go to the head, okay, it will face where I was, okay, so I was over here. It will move 1 block in that direction, okay, and then it will turn around and teleport me here. And what this allows is for that really nice looking behavior where it has some memory of where the previous piece was, so it doesn't just snap around, okay. It has some kind of memory going on because it is going to update the pieces based on where they previously were, but it also kind of locks the motion or the direction of motion towards the head. And then you repeat this process. So it is the same command, except instead of facing the centihead, you face the centipart 0, or the part in front of it. And you do this for centipart 1. Centipart 2, you face centipart 1. Centipart 3, you face centipart 2. And I believe this is what we refer to as forward kinematics, this kind of behavior, where you kind of have like a parent, and then the child bone faces gets moved based on the parent or something like that. But it might be inverse kinematics. I'm not really a professional at this, so I don't really know what the correct one of those two it is. But we kind of repeat this for every single part, so it ends up being 20 commands. And then we remove the this tag so that next time we run the search check, there will be nothing with the tag. Okay. One thing to note is @e remove tag is sometimes or often more efficient than having specificity, but it might be more efficient to have specificity. I don't know, but I don't really care because this isn't a pack that I'm releasing to everybody and saying it's the most efficient thing ever. It's for a map. Anyways, if you guys want to use this, feel free to use it and share it with others. Maybe leave some kind of credit somewhere to me in whatever you're working on somewhere. But anyways, thanks for watching, and I'll see you next time. Peace.